Hello, physical science class. This is your physical science 16B lab, page 177 through 179. I had wanted to look and see what options there were online and decided to just go ahead and video what I had wanted to talk to you about. A lot of other things have extra stuff. So what we're going to do is to look at radioactive decay. So this is really like, if we could say, it's the part B of the 16B lab, the second half. Hopefully you got your package in the mail with your supplies that you need. Radioactive decay is similar to what you're going to do with the M&M stuff, okay? With the M&Ms, there's some directions here if you have not already read them. I don't know if you have a full 40 pieces of candy for your box, but you'll need your bag of M&Ms. You'll need some type of a sandwich container box, or you could use a tray of some sort. What I had was a old card box, you know, that cards came in, and I just used that. But what you're going to do is shake your M&Ms in the box, and you're going to open the box and remove the candy that has landed with their logo side up. Okay, so if they have an M sticking up, that means they have decayed, and you're going to remove those, and you're going to leave the ones that have not had the decay. Okay, so then you're going to count those that are remaining, record them in your table 1 of this lab, and you're going to repeat it all over again. Okay, you'll do this again until all of your candy pieces are gone. Okay, so you're going to record that information, and it will be similar to the way radioactive decay behaves. Okay, there's an article here that's kind of interesting about medical imaging and how they can use something called Tectinium-99m, which is a radioactive isotope that's something edible that you can take, and it will help to highlight any specific organs the doctors are wanting to study. And so you might think, like this article says, how is this safe, right? If something's radioactive, that would seem dangerous, right? But no, Tectinium-99m is perfect for imaging because it has a half-life of 6 hours. Now you might wonder what a half-life even is. What I wanted to do, and I can't show you this without my book having the answers in it, so I want to discuss it on this paper. So if you're looking at page 178, question 11, you're looking at the fact that tectinium, so we're going to abbreviate that TC99m, that has a half-life of only 6 hours. So what that says is every 6 hours you're going to have half the amount of Tectinium-99 that you had in the previous 6 hours, right? So let's say, for example, you had 50 grams. Okay, it doesn't tell us this in the lab, but I want to just show you how you could figure out, right? So after 6 hours has passed, so 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour, you're only going to have half your amount of Tectinium-99 left, right? That means after 6 hours you would have 25 grams. And after another 6 hours, half of 25 would be 12.5 grams, right? And after another 6 hours, right, it's asking how much we would have after, how long it would take basically to be all gone. Then you would have 6.25 or 6.25 grams left. After another 6 hours, you would have 3.125 grams. And how you can figure this out is you would take 50 divided by 2, you'd get 25. 25 divided by 2, 12.5, right? So you're going to use this idea in some of the rest of your questions. We're not to nothing yet, so we'll keep going. After another 6 hours, you would have 1.5625. Again, figuring this out with my calculator. And then after another 6 hours, you're going to have 0.78 or nothing left, right? So 6 times 1, 2, 3, 4, 5, 6, right? 6 times 6 half-lives. It would take you about 36 hours to get none of the original sample left. Okay? So when it says using the data from your radioactive model, how long do you think it would take for all, right, every little bit to be gone? So within 36 hours, your body would have cleaned all of that out. Okay, they're going to ask you to be able to figure this kind of stuff in the next question. It says in question 12, what problem does using an isotope with a 6-hour half-life cause for companies that produce it, as well as for medical facilities that use it? So think about it in terms of something that a store would sell a lot of. Recently in these coronavirus days, toilet paper, right? Toilet paper companies cannot seem to keep toilet paper on the shelf. Everybody keeps buying it and using it, right? So think about that like your Tectinium-99. If something is being used up very, very quickly, how is that going to be problematic for the companies that manufacture it and also the medical facilities? Okay, so that's for question 12. And then, so I would like for you to answer that. And then we're going to do one more question. It's question 13, and it's with a Tectinium-99M generator. Okay, so look at this. Says a Tectinium cow. That means something that's going to be a generator of Tectinium is being contains something called molybdenum-99. This is an isotope, has a half-life of 66 hours. Okay, so it's a little bit longer, right? 6 hours versus 66 hours. As it decays, it turns into Tectinium-99M. The technicians milk the generator by running a saline solution through the isotope to collect the radioactive particles. A Tectinium cow produces useful amounts of Tectinium-99 for about 3 half-lives of molybdenum-99. How often would a nuclear medicine facility have to order a new cow? Round your answer to the nearest day. Okay, so we're going to use a couple things when we're figuring this question out. A couple pieces of important information. 66 hours is 1 half-life. Okay, and it says we need 3 half-lives. in our answer. Actually, I guess it would be half lives in our answer. So, so what you're going to do is to use this information. You're going to multiply it together and you're going to get some number. Okay. Then it says, it asks us how often or how many days would it take for you to be able to order, right? And so what you're going to do is think that every day is 24 hours, right? So 24 hours divided into this number is going to tell you how many days that it will last, okay? So I would like for you to go ahead, do your candy if you have not already done it, record your results in your table 1, again, if you have not already done it, and do your graph on the radioactive decay model, which means you're going to be graphing these numbers onto this graph. Then answer the questions and take a picture of it or turn in the hard copy and you'll be all set. Thanks. Hope you have a great day.